Hi, welcome back to the last video of the Smart Pipeline tutorial. And so we're basically done forward warping the data set, and I showed you in the last video what the data set looks like, but these functions down here are basically collections of functions that allow you to more easily parse apart your data and look at just regions of interest that you want to look at. I also introduced a bunch of new visualization plots, some based off of the original base package in WholeBrain, and some new data organization functions. So let's just get started with the get ROIs function first. So this function is pretty straightforward. It's basically in the name, but this allows you to take a subset of the cell counts in your overall data set and just get the regions of interest that you want. So let's just set this to a variable called ROIs. All right, and we'll call the get ROIs function right now. So you'll see that data set. You'll see that the required argument is dataset, and if you don't specify your regions of interest, they'll default to the comments in the central amygdala, just because those are fun regions. So I'll just copy and paste that just to explicitly show you that I'm pulling from just the comments and the central amygdala, right? And so this, let's run this. Oh, so by the way, the argument for the ROIs needs to be set to a vectorized string, a vector of strings or characters, where the characters are the region acronyms straight from the LMS Brain Atlas. So they need to match up to what's listed on the LMS Brain Atlas website. Okay, so if we look at ROIs, we can see that it looks really similar to the overall dataset, but if you go to the acronym table, you can see that all these cell counts are either from the comments or from the central amygdala, and it includes cell counts from the subregions of the central amygdala. Okay, so you can combine this function with a lot of plotting functions in the base package. So, for example, there's something called a dot plot in the base WholeBrain package. And so in order to create a table or a dot plot, we first need to pull up the graphics device. And dot plot just basically plots your data set into a nice organized table for you. So let's run WholeBrain dot plot, right? And what we need is, you can see the arguments here, data set, but our data set right now is our regions of interest. And we want to set device, because we already pulled one up. Okay. Now let's see what that looks like. All right. And you can see that I've just pulled up a dot plot for you guys. And you can see, well, it looks a little sparse right now, but you can add as many ROIs as you want to make this look like a really nice table. Let's just go graphics off and get rid of all graphics devices for now. Okay, so that's the get ROS function. The next function I want to explain is the sunburst function. So this is a really fun function that produces a interactive plot, a sunburst plot. And so let's just read through the documentation really quick. So it requires your entire data set as an argument. And you could specify regions of interest. It defaults to the cortex and the brainstem, which basically accounts for almost all the regions, all the cell counts in the brain. So the default is to plot basically your entire data set. And I'll explain what the parent argument is. Probably better if I show you by plotting a sunburst first. But you can see that the value returned from this function is a sunburst object. Right? So let's just set this to a variable that we labeled sunburst. Okay, and we're going to run it. This might take a little bit of time. Shouldn't be too long. Okay, so we can display the sunburst. by just typing the Sunburst object in the console, and we'll pull up the interactive graph. So let me just expand this really quickly. So you can see that as I'm hovering over some of these different arcs in the Sunburst graph, that the region names are showing up. So basically this keeps account of the hierarchical relationships between regions in the brain. So you can see that the innermost region accounts for all cell counts in the brain that are labeled as gray matter. As you go progressively towards the outer rings, you go towards more and more subregions, and they're color-coded based on the Allen Mouse Brain Atlas colors, and the actual arc length is relative to the overall number of cell counts in the brain. Okay, so let me just explain some of those other arguments in further by running the ROIs function. Let's create a new variable, Sunburst 2, and let's just copy the usage. But instead, let's add, let's just plot the accumbens and the central amygdala. Right? And the default is to set the parent argument to true. Okay? So the parent argument is important because it sets the base layer of your Sunburst object to gray. Right? So you can see that in the outermost rings that we're getting cell counts from the amygdala and from the accumbens, right? Those are the outermost rings over here. But if you set parent to true, it traces back these regions to a mutual parent, and it displays just the mutual parents of the amygdala and the accumbens, and it traces it back to the gray core layer. Right? So if you set parent to false, what happens is, and this would be easier if I first had amygdala in the front. Okay? You'll see that what happens is it takes the very first region that you entered in the ROIs argument, and it automatically sets that to the core base layer of the Sunburst plot, and then it plots any subsequent subregions. But because you can't have multiple core layers, the default is to just take the very first region as the core layer, and it just basically ignores any subsequent subregions. And so that's why if you want to plot multiple ROIs, you want to set parent equal to true. But if you just want to plot one region that has a lot of subregions, like let's say the hippocampus, right? I think that's the region acronym. Let's set parent equal to false. Whoops. It's probably the wrong acronym. Okay. So, yeah, this is a lot less colorful because, all of the hippocampus colors are basically the same, but the hippocampus is the base layer, and you can see a lot of these subregions. So this is a nice way to look at one particular region that has a lot of subregions. Okay, let's move on to the next function, the getTree function. You guys might not need to use this that much, but this is just another way of organizing your data. In fact, the getSunburst function that I just showed you guys uses and calls on the getTree function. So this is just a way of showing the hierarchy relationship between regions in your dataset. So let me just explain. getTree, and this returns to a tree. It returns you a tree. So okay, just to explain what this does, this just returns to you cell counts in a given region that are unique to a brain region. For example, in this region, within the subiculum, this subregion contains 322 cell counts, and it also gives you the actual color code for the color of this region, and it also tells you all the parent regions trace back all the way to the gray core layer. And so some of these regions contain 0 cell counts because either the forward warp didn't detect any cells in these regions, or these regions contain subregions and their cell counts are contained there. So that's the get tree function. Let's exit out of that and let's go to the next plot. The next plot is the glass brain function. Okay, and this is a visualization function that's most closely related to it's really closely related to the original glass brain function in whole brain. In fact, almost all of the arguments are the same and it looks really similar, but there's just one change to the argument, and that's here. It's under high res. Okay, so this is an original argument in whole brain that had the options true or false, but now if you enter in off in quotes, you can actually take away the outermost glass brain that normally pops up. So let me show you that really quick. Let's just take the default for everything. Oh, sorry, there's one more new argument, and that's called jitter equals false. So let's run this, and I'll show you what this does. All right. So you can see that we have an interactive glass brain plot, but something that you'll want to notice is if you zoom in, you can, it might be kind of hard to see, but you can actually see these straight lines, right? So each cell has been given a Z position based on which image in your data set it has been placed as. So each cell has a centroid most point. The Z image, or the Z number of the centroid most point, is where that cell has been placed, right? The original glass brain function contained this space filling jitter that didn't actually place the cell count in the exact Z position of where your cell count lies in your data set. So this accounts for that, and it gives you the option to apply that jitter along the Z axis or not. And so you can see that without the Z jitter, you can see very clearly where your cells are. But that's just for, visualization purposes. It doesn't really do much in terms of actually analyzing the data set. Another thing I want to point out is that normally there's this glass brain that is above your data set, but this gets rid of that, so you can actually just see what the cells look like just plotted. And you can see the outline and the shape of the brain pretty well just by plotting it like this. So you can feel free to turn that glass brain on or off. So let's try setting the glass brain on and seeing what that looks like. And so you can see that, you can see where the cells plot within this larger gray brain contour. Okay, so that's the glass brain 2 function. So the very last function is the get table function. So this is a really nice function that just organizes your data for you. And you can specify a subset of regions of interest that you want to create a table of. Over here with the region, with the ROIs argument. And you can see that this returns a table. Okay, so let's store this as a table. And let's just set the ROIs to, just for consistency. The commons and the central medulla. And you can see something really nice that this function does is it creates a table of the regions of interest that you want, right? the actual cell name, or the full name of that region. It gives you the hierarchical path, left-right cell counts, overall cell counts, the left-right cell count ratio, and percentage of cell counts. So this is a really nice way of looking at your data. Okay, so that's it for all of the plotting and visualization functions in the SMART package. Okay, so that's basically it for the SMART video tutorials. So there's a lot more documentation in the help pages and in the online tutorial website over here. So before I let you go, I highly recommend you read through all of the documentation. But if you guys have any questions, you can reach me at the SMART package email, and or DM me at my Twitter. And also be sure to check in the updates tab on the website for any updates and functionality to any of the SMART functions, or check for any new functions that might appear. Okay, so without further ado, happy brain mapping.